This video is to walk through a step-by-step version of the algebra method for solving difficult balancing problems. Usually more of a guess and check version is just fine for balancing. In fact, it's going to be quicker than algebra, but for the particularly challenging ones, algebra can be a way to get this done. So it's going to look like this. You're going to start by assigning a random variable, whatever you choose, to each of your coefficient blanks. And then your goal number one is going to be to get into terms of one variable. So in this case, I either want all three of them to have something to do with x, all three of them to have something to do with y, or all three of them to have something to do with z. So I have iron and oxygen, and I'm going to take my iron and say, what can I learn from iron? Well, regardless of what goes in the blank, I know that I am going to have X irons on the reactant side. And I have to have the same number of irons on the right side, so that means it has to equal. And on the right side, I'm going to have Z times 2. So whatever is my coefficient, I'm going to multiply it by 2 for the number of irons in that molecule. And I'm going to have 2Z irons on the right side. So I currently have a total of X irons on the left. I currently have a total of 2 times Z irons on the right. And those two numbers will ultimately have to equal one another. If X equals 2Z, then I can get rid of X and have 2Z be in its place. So this is what I mean when I say we're trying to get everything into terms of one variable. Now I know that whatever coefficient goes into the right side of iron oxide, I'm going to have a number that's twice as big for iron. This is everything I can learn from iron, so now we'll go on and see what we can learn from oxygen. I currently have 2 Y oxygens on the left side, and I have 3 Z oxygens on the right side, and the left always has to equal the right. 2Y equals 3Z. Now at this point, it doesn't matter what we solve for. I'm either going to turn all of my Z's into Y's, or I'm going to turn all of my Y's into Z's. I'm going to choose that second one. I'm going to solve for Y so that I can make this middle variable turn into a Z. So if I divide both sides by 2, I get Y equals 3 over 2Z. So let's just clean up the top and make it look nicest. This is 2Z, and this is 3 over 2Z. So I have everything in terms of one variable. Step 2 is remove any fractions by multiplying by the denominator. So I can see that I have a 2 in the denominator over here. So I'm going to multiply this entire equation by 2. And I'll put my answer down here. 4Z times iron plus 2 times 3 over 2 is 3Z for my number of oxygens will yield Z times 2 is 2Z for my number of iron oxides. Your last step is going to be simplify. I will just say simplify. At this point, 4, 3, and 2 don't have any common factors, so I can't simplify that, but I can get rid of these variables, effectively divide the whole thing by Z, and that cancels out all of my Z's, and I end up with 4 irons plus 3 oxygens yields 2 iron oxides. And that is the whole technique. We can draw out these particles if it's helpful. So I'll use different colors for iron and oxygen. Maybe iron can be like a dark pink. I have 1, 2, 3, 4 irons. And we've been using this blue color for oxygen. I have 1, 2, 3 oxygen molecules. And I'm creating 2 molecules that have 2 irons and 3 oxygens. 1, 2, 3. 1, 2, 3. So the question is, did we successfully preserve, oh, I made iron the wrong color. Well, we'll just make these ones purple. Purple. So at the beginning, I had 1, 2, 3, 4 irons. 1, 2, 3, 4 irons. I had 1, 2, 3, 4, 5, 6 oxygens. 1, 2, 3, 4, 5, 6 oxygens. So in order to create this more complex molecule, Fe2O3, I need 4 pure iron atoms, 3 oxygen molecules, and I will always end up creating 2 iron oxide molecules. That's the algebra method. Again, it can be tedious for the simpler problems where you'd rather just use a t-chart or even do it in your head. But for some of the most difficult problems, you'll end up maybe even needing this algebra technique. Let me know if you have any questions. Thanks. Bye.